To use the linked list internally to implement a stack, first create a class representing a node in the linked list. Then create a stack class using the link internally. Using the operations such as push int data, create a node and link it to the current top of the stack. This operation of adding a node at the head of the linked list has a constant time operation or O1. Check if the stack is empty and store the value of the current top node. Move the top to the next node and return the stored value using the pop operation. This operation of removing the top node or adjusting the top pointer is a constant time operation or O1. Use getTop to return the value of the top node without removing it. It has a time complexity of O1 or constant time operation since it is accessing the value of the top node. Return true if the top is null or an empty stack, or false using the isEmpty method. This checks if the top is null or empty and has an O1 time complexity or is a constant time operation. To implement a queue using a linked list internally, first write the class node to define the structure of a node. Next, implement the queue using a linked list. Use operations such as enqueue to add an element to the end with a time complexity of O1. Then use the queue to remove an element from the front with a time complexity of O1 also. Maintain the size of the queue by using a count variable which is updated on queue and the queue operations. This process has a time complexity of O1. Return true if the front is null or false using isEmpty. This has a time complexity of O1.